Hello everyone, welcome back to Educately Geography. Today we're going to be talking about mountains and volcanoes, so let's get started. Today's objective, we're just going to explain what mountains and volcanoes are and how they form. So mountains, a mountain is a landform that rises at least 1,000 feet, which is about 300 meters above its surroundings. That definition isn't 100% agreed upon because sometimes, the difference between a mountain and, say, a hill is a bit more subjective. But this is one of the more technical definitions that's good to go by. The highest point in a mountain is known as the summit. And oftentimes you won't see mountains just appear and form like individually. They will form in groups, which are known as mountain ranges. And sometimes you have mountain ranges that aren't necessarily connected together, or they have like small distinctions amongst themselves. And usually these close, similar mountain ranges are known as mountain belts. And usually they form from one geological process. So, for instance, two specific tectonic plates merging into one another that might create several mountain ranges in different areas. That group of mountain ranges might be known as a mountain belt. How do mountains form? I kind of just alluded to this. Most mountains form as a result of converging tectonic plates. So, an example of this, let me turn on my pointer. An example of this can be seen in this diagram to the top. You have two continental crusts in this picture. They don't necessarily both have to be continental, but oftentimes that's how it is with mountain ranges. They collide head on, which creates a crumpling effect toward near the border of the two plates. Sometimes one of them goes a bit underneath, especially one of them is oceanic. Usually the oceanic crust goes below the continental one. But in this case, you have two continental plates, that creates this crumpling effect, which is a mountain range. An example of a mountain range that has formed because of converging plates is the Himalaya Mountains. The Himalayan mountains contain the largest mountains in the world. Usually that's how mountains form. Sometimes, though, they form due to transform boundaries, which is when two tectonic plates kind of grind past each other without colliding head on. They just kind of go to the side. Sometimes one of them can, then, in parts, go over the surface of another in certain areas. An example of a mountain range that's kind of been enhanced by that is the Sierra Nevada range in California. Sometimes mountains can also form, or at least become more prominent as a result of erosion. So because of weather, like thunderstorms, lightning, rain, overtime, precipitation, that can lead to certain features of the mountain becoming more enhanced over time and more rocky, for instance, rather than hilly and more steep. So yeah, that's how mountains can form and also mostly just become more distinct. So let's move on to volcanoes now. A volcano is an opening at the surface that allows magma, which is just melted rock from the mantle of the earth, and it allows that magma to escape. When that magma does escape, that's known as an eruption. And these eruptions, aside from releasing lava, lava is the term for magma once that magma reaches above the surface, eruptions can also release gas, cinders, and ash. And many of you, I bet when you think of volcanic eruptions, you think of these massive, violent explosions that just send rock and lava and magma, lava everywhere. But that's not necessarily true because, or it can be true sometimes, but oftentimes volcanic eruptions are actually somewhat peaceful. It really depends on the presence of gas and the viscosity of magma when that eruption occurs. So there are sometimes gases that cause that more explosive reaction in some eruptions, and oftentimes when the magma is more viscous, which means that it's more thick and it's less like a liquid and more, it's more thick in a sense. Usually magma that's more thick is involved in more, explosive eruptions that have more gas. So here are the parts of a volcano. As you can see, you have a magma chamber towards the bottom inside the earth that kind of leads into a main vent, which is where the main lava or the main magma in this case rises into the volcano. The main part where the magma, I guess now it's lava, escapes is known as the crater. But sometimes you have secondary vents that emerge towards the side of the volcano where less magma or lava escapes, but there's still some. When you have a less violent eruption, you have lava flow, which is just lava oozing out of the top, not necessarily exploding violently. But you have these volcanic bombs when you have, as the name suggests, it's a violent name. That's because you have these massive rocks that are getting thrown violently out of the volcano. That's characteristic of more violent eruptions. So how do volcanoes form? The first way they form is from divergent plate boundaries. This isn't how mountains form. This is unique to volcanoes. But basically, you have two tectonic plates that move away from each other. As you can see with this picture, they kind of just separate. And what this up arrow right here suggests is that magma from inside the Earth, it can kind of like has more room to just seep through and escape the Earth. And in that sense, that's how one way volcanoes will form. A second way, this is a bit more similar to how mountains generally form. This is through convergent plate boundaries. So the thing with mountains is mountains often happen or form as a result of two continental crusts colliding into one another. But sometimes with volcanoes, and most of the time, you won't see two continental crusts colliding. You'll see at least one of them be oceanic. Because when you have an oceanic crust, because they're not as buoyant as continental crusts, they can sink like completely, or parts of them can sink completely below the continental crust, and that creates an area known as a subduction zone. This act is known as subduction, and it's kind of a complicated process. But once once the oceanic plate subducts, there's like minerals inside the crust of the oceanic plate that escape into like the mantle of the Earth, and when those minerals escape, like the water is released into the mantle rocks, and that water lowers the melting point of those rocks. And because it's hot inside the Earth, then those rocks now have a lower melting point. They often melt into magma. And when you have that magma, it just takes something to just make it seep through, sometimes cracks into continental crust. And as you can see with this picture, sometimes they just seep through and reach the surface. And the reason you have mountains once this happens is, again, because they're convergent plate boundaries that creates this crumpling effect. And that's why you often see mountains with that. They're not just random holes in the ground necessarily. They can also be a part of mountains. So yeah. This process also forms features known as island arcs, as you'll see on this slide. This example it's a picture of a map southwest of Japan and east of Taiwan and the Asian continent. So basically, as you can see, you have like a series of islands right here. And what happened, how these islands formed, it's because you had the Philippine plate, which is to the east. That was an oceanic crust. Meanwhile, you have the Eurasian plate right here, which this part is also oceanic. You can sometimes, subduction zones can still occur when you have two oceanic crusts. One of them is less buoyant and sinks underneath the other one, though. So what happened here is because one of them subducted, that created just a chain of volcanoes and volcanic islands around here. And that's what an island arc is. It's just a chain of volcanic islands that occurs as a result of a subduction zone. There's a third way volcanoes form, and this way is known as hotspots. So hotspots aren't necessarily a result of tectonic plates, and because they're not a result of tectonic plates, it's a bit more unique. In fact, there's no really definitive explanation for these types of volcanoes. They're kind of just there. There are some hypotheses that suggest why they may occur. One example is that scientists think that there are like just hot parts to the mantle that causes magma to just form underneath the surface because of rocks melting because of these hot areas. Those just seep through and then cause volcanic eruptions. Another hypothesis is that it has nothing to do with temperature, actually. It's just that some areas of the Earth are more prone to having magma seep through than others because of just the way the land is structured. There's two good examples of this right here towards the bottom left. This very colorful example. This is in Yellowstone National Park. There's a supervolcano there. At Yellowstone, it's not anywhere near a tectonic plate boundary, so that's likely not a cause, because of a tectonic plate diverging or converging, but rather it's just a hotspot, as scientists call it. And this other example is from Hawaii. It's a volcano in Hawaii. Hawaii actually isn't an island arc, and it's actually nowhere near any tectonic plate boundary. It's in the middle of, I believe, the Pacific plate. And it's just happened as a result of a supposed hotspot that's there. Whether or not there's like an actual physical rise in temperature underneath Hawaii, scientists have not figured out yet. It might just be because the geography there permits more magma to erupt, as we just stated. But yeah, it's not because of the divergence or convergence of tectonic plates. But yeah, that wraps it up for today. Hopefully you learned something about how mountains and volcanoes form. But yeah, so if you need any other help with any geography or also other subjects. We have plenty of subjects here at Educately. Just browse through our site. Feel free to do that. But this does it for today, so thanks for watching. Have a nice day.